Hi, so in this video I'll take us over our first probability tutorial sheet. So these are the first questions we're going to answer. Okay, there are about 7 questions. Okay, so let's get started. Write the sample space for each of the following experiments. Okay, so in our videos, in our introduction to probability, we've established that a sample space is a set of all possible outcomes of an experiment. Okay, so the first one is we need to write a sample space for 3 tosses of a coin. Okay, so in our earlier examples, we've looked at 2 and 1 toss. So now let's look at 3. You toss a coin 3 times. What is the sample space? Okay, so I left this space deliberately to just demonstrate that. Okay, so when it comes to tossing a coin, we've got 2 possibilities in each toss, right? So if you toss a coin, the 2 possibilities you have is you're going to get either an head or a tail. That's a single toss. Okay, now if you toss again another coin, the good part about this is the way a coin works is these are independent events. What you get in the first toss does not affect what you get in the other one. There is no effect. So in the second toss as well, suppose you got an head in the first toss. In the second toss, you still have 2 possibilities again without them changing. Okay, now suppose the other possibility, you can't rule out this one as well. So it's still possible that in the first toss somebody got the tail, and then in their second toss they can still have a chance of getting again head and tail. So this is what you would actually indicate uh, for the two. So if this was the first toss, this is your second toss. So if you're tossing a coin twice, this is where you would end. Okay, meaning that what you're saying is, okay, suppose in our first toss we got an head. In the second toss we still have possibility of the other two. But again, it's possible we might have gotten a tail in the first toss again, still leaving us with the other 2 possibilities. So if you had to write down the sample space for tossing a coin twice, you find that you end up with 4. So head, tail, tail, head, tail, tail. So that's how you come up with a sample space. Now for 3, tossing 3 times, you have to extend. Okay, which makes it even more interesting. We call this a tree diagram, by the way. So again, you still maintain edge tail, edge tail, edge tail, edge tail. Now if you count what you have at the end, 1 2 3 4 5 6 7 8 branches. So we should have 8 possibilities there. And how do you list them down? You start from here. Head, first branch, head, tail, head, just like that. So our sample space will be made up of first one, head, then it will turn at head, and then go to tail, and then we'll go to this branch. So head, tail, head, and then head, tail, tail. Okay, I'm at liberty of now removing this. We can go to the other branch down, tail, head, tail, head, tail. I'm on this one now. That would be tail, head, and then tail, tail. So you see, that's how you come up with a sample space. I hope this has opened up your mind when it comes to coming up with the sample space using a tree diagram. Now for B, we are told a box contains 4 marbles labeled A, B, C, and D. 2 items are selected at random without replacement from this box. Okay, again, I want you to pause the video. So when they say without replacement, what that implies is these are not 2 independent. The selecting of 2 marbles doesn't become independent. Okay, because there's a condition you are not replacing. So what that implies is in our first draw of getting a marble, we have 4 possibilities, right? A, B, C, and D. So if I was to draw a tree diagram, I'll draw something like this. 1, 2, 3, and 4, right? Not so perfect. Let me do this. Then like this, and then like this. Okay, so let's say A, B, C, and D. This is our first selection. That's our possibility for our first selection. Now for the second one, if you haven't replaced, suppose you got an A in your first selection and you don't replace, you are going to remain with how many possibilities? 3 possibilities. If you get B as well without replacement, so we're not exactly sure what happened. So this is what probability is all about. We're just trying to determine the chances, the likelihood. So if suppose you got an A, you would remain with a possibility of getting B, C, and D in the other selections. Suppose you got a B, you would remain with the possibilities of getting what? A, C, and D. Possibility of getting B. Let me start with A. So A, B, and D. Possibility of getting A, B, and C. So if you've paid attention and you've seen what I'm doing here is, since they said without replacement, you got 2 items randomly from the box without replacement. So assuming we got an A, in the second selection you only have 3 choices or 3 possibilities. The same applies to all the remaining ones. Now if you count them, you see that we've got 12 possibilities, right? So we're going to have 12 members in our sample space. I've shown you how to come up with a sample space. Okay, so just look at the branches. So the first one is AB, second one is AC, second possibility is, the third one is AD, BA, BC, BD, CA, CB, CD, DA, DB, DC. 12 possibilities. That is our sample space. Now the same question is repeated. Now here they said the label is noted and put back in the box. The second marble is selected and the label is noted too. So this is where you replace. Okay, the only difference there is what do you think would be the difference before I actually tell you what the difference is? So when we say there will be when they say there will be replacement after a draw, it implies as you get again, as you make a third, as you make a second attempt or a second selection, everything is back to normal. So instead of having like the whole restricted after selecting A, you only remain with 3 possibilities. There will still remain 4 possibilities because you've replaced. So even suppose if you got an A, the A is put back. So you still have a possibility of getting an A again. So all these would go back to 4 branches. 4 branches, just like we did on the tossing of a coin, because on the coin you can't remove the head or the tail, they will always be there. So that's how you can relate the marble selection without or with replacement. So B would equally be present there, C would be present, and D would be present. So you end up with 4 times 4. This will be 16 possibilities. Okay, you can list that down. And then we are told 1 toss of a coin and 1 roll of a die. This is very simple. So we have 1 toss of a coin. Tossing a coin, you have a possibility of getting. Can you pause the video and just try to write the sample space for that? I just want to see if you understand what we're doing here. Okay, so you've got a possibility of getting an head or tail for a coin. So suppose you got an head in the first in your toss. On the roll of a die, you still have 6 possibilities. Again, there you have 6 possibilities, 1 to 6. Okay, so 6 plus 6, you end up with 12 possibilities. So that is what you have in your sample space. Okay, head 1, head 2, you're mapping to the numbers, right? Head 3 all the way up to 6, right? Okay, so 4 all the way up to 6. Again, suppose you got started, you got a tail, so T1, T2, all the way up to T6. That would be your sample space for this one. Okay, question 2. In a group of students, some own cars, others do not. If 3 students are randomly selected from this group, write the sample space and show it on the tree diagram. List all outcomes included in each event below and indicate which are simple events and which are compound events. Okay, so let's try to pay attention. So we have got a group of students, some own cars. So let's use all for the people who own cars. Own cars. Others do not. If 3 students are randomly selected, so the ones that do not, we can use N, right? Do not own cars. Okay. If 3 students are randomly selected from this group, write the sample space and show it on the tree diagram. List the outcomes included in each event below and indicate which are simple events and which are compound event. Okay, so we have 3 students selected at random. Okay, now in the selection of the first student, we have how many possibilities? 3 possibilities. Okay, meaning that the first student we are selecting can either, no, actually not 3 possibilities, only 2 possibilities. The first student that you're selecting can either own a car or not. That's all. Now for the second person as well, there are also just 2 possibilities. They can either own one or not. Own one or not. By now I believe you understand why we're writing this like this. Because suppose the first person owned the car, it doesn't change the possibilities of the other person. They will still either own a car or not. They are independent. Again, suppose the first person actually didn't own a car. The other person is still not affected. They can still either own a car or not. So this is for a first person, this is for a second person. Now you can go to third person. So equally as well, you can either own a car or not. So you can say own a car or not. Okay, own a car or not, own a car or not, own a car or not. Okay, don't mind though I've drawn the tree diagram, just lack of space. What I'm trying to point out is the fact that we have own a car or not at each branch. So how many possibilities do we have here? 1, 2, 3, 4, 5, 6, 7, 8. Okay. You can actually list them. That's what the first part of the question is saying. So we've shown the tree diagram, write the sample space. So how would our sample space be? So you look at the branches. Let me draw it properly now. So for a third person, this is our possibilities, like that, like this, like this, like this. Okay, so own a car, not, own a car, not. So if I were to list them down, the first branch would be on, or. So or. That implies all the 3 owned cars. The other one is 2 of them, or, and then n, and then o n o n o, o n o, and then o n n. Then if you go to this other part, n o o, and then n o n, n n o, then n n n, meaning that they all didn't own cars. There should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're good. Now the question is, list all the outcomes included in each event below and indicate which are simple events and compound events. So A single outcome in a sample space is a simple event. When you have more than one, they become compound events. Okay, so exactly one student owns a car. So where do we have only a single car? Where do we only have a person owning a single car? So where there's only a single or, exactly one student owns a car. So I can see this part only one or, that part only one or, and that part only one or. So if we're to list that, we're going to have O N N, N O N, and N N O. So these are the possibilities. Exactly one student owns a car because the presence of an or, but then we already have more than one, so this is a compound event. Okay, so this is exactly how they are expecting you to answer these questions. Okay, so you've seen how useful a tree diagram can get for some complex situations that may waste your time when it comes to just you looking. Okay, so let's move. So I want you now to have the confidence to pause the video and try out what are the ones that are remaining. So the first student selected owns a car. The first student. So meaning that where we had an or, that implies the first. So whether you have an or, those were actually four possibilities actually. See where we started with an or. So if you list them, there are four. You can list them. So already you know that's a compound event. Go to C. At most one student owns a car. At most one student owns a car. So maximum one student owns a car. So meaning that one or less. So you still see that we're still going to have a lot of possibilities, right? One or less. So this one, this one, this one, even including the one where no student actually owned a car. That's also part of at most one student owns a car. So that is still a compound event. Not more than two students, not more than two students on a car. So two or less. Two or less. So two, this is also less, two, less, one, none. So the rest, except the one where three of them um, are likely to own. So it's all these, which will still make it a compound event as well. Now we're on question 3. A fair die is rolled twice. Find the probability that the two fives are obtained. A fair die is rolled twice. Find the probability that two fives are obtained. So these questions where it's as simple like that. Okay, so what's the probability of getting a 5? Okay, in the two in the rolling of a die twice. Now the question is, are these conditional probabilities? Is this conditional? Okay, are these dependent or these are independent events? These are independent events in that you getting a 5 in the first row doesn't affect the other one, right? Just like the coins. Yeah, the first result in a coin, head or tail, doesn't affect the second uh, coin toss. So equally here for the die as well, you know it has got fixed 6 sides, so it doesn't actually change. So what do we say in that case? So these are independent events. So therefore, them being independent events, the probability of getting 5 twice. Okay, so 5 twice. So the probability of getting 5 twice is given as the probability of getting a 5 in the first row multiplied by the probability of getting a 5 in the second row as well. They are independent events. So what's the probability of getting a 5? Remember, you've got 1 to 6. So if you roll a die, the probability of getting a 5 is 1 over 6, because you only have a single 5 out of 6 possibilities. Multiply by the other one. These are independent, so they are not affecting their values. So you see that your answer will be 1 over 36. Okay? So if you are a person who hasn't learned my introduction to probability, you'd want to use the link in the description below and head over to our site where you learn the topic from scratch, from the definitions, the theorems, other practice questions, okay, explaining all kinds of probability, conditional probability, independent events, and everything that you need to know, mutually exclusive events. Yeah, everything you actually possibly need to know under probability is covered on our site. You can use the link in the description below. Then a group of 50 people was asked which of three newspapers, A, B, or C, they read. Their responses showed that 25 read A, 16 read B, 14 read C, 5 read both A, B, 4 read both B and C, 6 read the probability, 6 read both A and C, and 2 read all three newspapers. Represent the data on a Venn diagram and then find the probability that a person selected at random from this group reads only B, only A, only one of the newspapers, at least one of the newspapers. So how do you approach this question? The best way to approach this question is answer it as a normal set question. As a normal set question, I'll repeat, as a normal set question. So I want you to just take a few seconds and try to approach it as you'd approach a set questions by drawing the Venn diagram, indicating A, B, and C. Start from the center of all the people that read all the three, okay, and then let's see where we pick it up from there. Okay, so you can pause the video. Okay, so let's draw something there. Okay, we can move this now. Let's draw something again. Okay, move one more, let me change. Okay, so we move it there. Alright. Okay, I think we're done now. Okay, forget about me wasting time to draw a fancy Venn diagram. Yeah, you can still move this. Draw. Okay, so let's just get into it. So let's call this A, B, and C. So I hope you've taken time to draw a Venn diagram as I was drawing mine. So we'll start always at the center. So 2 read all three newspapers. 2 read all three newspapers. Okay. Then you go now to the intersections. So as we go backwards, you see that 6 read A and C. So A and C, where is A and C? Here. So 6 of them. So you remove the 2, you get a 4, right? So that 4 plus 2 are still 6. Then 4 read B and C. B and C, 4. So minus the 2 again. So you remain with 2. Then 5 read both A and B. So minus the 2 again. That gives you a 3. Then 14 read C. So where is C? Here. So 4 plus 2, 2, that's 8. 8 minus 14, that should give us a 6. Then for B, we're told 16 read B. So 3 plus 2, 5 plus 2, 7. 7 minus 16, that should give us a 9. Then for A, what do we have for A? So we are told that 25 read A. So 3 plus 2, that's 5 plus 4, that's a 9. So 9 removed from the 25, it remains with 16. Okay. So we were told we had a group of 50 people, okay, who were asked which of the newspapers they read and whatnot. So let's try to add up some of the numbers that we have inside. Okay. 16 plus 9 is 25. 25 plus 6 is 31. 31 plus 4 is 35. Plus 2, 37. Plus 3, that's 40. Plus 2, 42. So 42 from 50 gives us 8. So 8 implied they read nothing. Okay, that's how you get to the Venn diagram. So we are done with the Venn diagram. Now you can use the Venn diagram to answer the questions that follow. So we are told, after you've represented the data on a Venn diagram, find the probability that a person selected at random from this group reads only B. So which part represents only B? So only B is a 9. So that would be 9 over the total possibilities. How many people did we have? 50 people. So 9 over 50 is the answer to A. For B, only A, what do you think would be the answer there? So only A is 16. So 16 over 50. You can divide by 2. You'd get something like 8. That would be 25. Then for C, only one of the newspapers. Only one of the newspapers. So only one. So it's either 16, 9, or 6. You can add them. 16 plus 9, 25. Plus 6, that should be 31. So 31 over 50. Then D, at least one of the newspapers. At least one. So at least they read something. So only 8 is not part of the at least. Everybody else reads at least one or more. That's what at least means, one or more. So all the 42 people inside qualify for that. For 42 over 50, of course you can divide that by 2, you'd get something like 21 over 25. Okay, so that's how you handle question 4. Okay, so question 5, 6, 7 will be available on our site. Use the link in the description below to head over to our site and access the solutions and learn the topic in full, and have access to all the math topics from set theory all the way up to calculus. Everything is covered: trig, binomial, logs, functions. Anything that you need to learn in math is already covered for you. Okay, see you on the other side. Thanks a lot for watching. Give me a comment if you've understood or you have a question.